And this gives you Cape-wide information. So what I want to show you is a different way. You get all the bar graphs and the numbers of looking at the economic data. Another way to look at it, though, is map-based. And this is where the GIS function really comes in. So this is that map of the Cape that we start and end every watershed presentation with. The gold shows you the town boundaries. The rest of it is the watersheds overlaid on it, 46 of them nitrogen sensitive. The blue watersheds are those watersheds that cross town boundaries, and the gray ones are those that are contained wholly within one single town. So you can see 2/3 of these watersheds cross town lines. So how are you going to meet TMDLs unless the towns are working together? But when we look at the nature of the problem and septic systems, and 80% coming from wastewater, on-site disposal, and then we get into these McConnell land use maps. This is what the Cape used to look like in 1971, with the green being open space, yellow being residential. That's how it looked in 1995. That's how it looked in 1999. So you can see that residential development, there's on-site wastewater disposals, that highlights the problem. And this is our sole source aquifer, and we get into a lot of this other stuff that I'm not going to go into with you right now. These are our density maps. These are value-added maps right here. These are maps that we did in-house. We're looking at different ways to measure density based on parcel dots or length of road between households. That's this map. And this all factors into capital facilities. If you are going to have capital intensive, where does it make sense to do different kinds of technologies? This is our regional wastewater management plan. These are our options, and these are the costs. You know, if you sue the entire Cape, $8 billion. Estimates to get where we need to be to meet TMDLs about $3 billion. If we allow build-out to go forward, it doubles that cost. But these are the demographic slides. So again, the watersheds on the town. But this shows you population density. So now if you can imagine all the economic data that you just looked at and how that's going to intersect with this census group block data that we have on population. The darker areas are more populated. Then housing units per square mile. So you can see where the housing units per square mile, where that density is. And most of our wastewater problems on the south side. You can see the density on the south side. Population change between 1980 and 1990. The darker areas are more dense. That's the base right there, and so that jumps out only because it's one big parcel. So we have to factor that into our analysis. Between 1990 and 2000, between 2000 and 2009, blue areas actually show a decrease in population. So if we look at the aggregate between 1980 and 2009, you can see where the density has happened. But if we go back to the population maps, you can see that the population starts on the coast, and the Cape, you can start to see a differentiation between the Old Kings Highway and Route 28. And those coastal properties that filled in first, and then the middle that fills in after. And so this is our Cape-wide share of seasonal homes. So to Austin's point, there you go. You want to talk about the seasonal economy? There it is. And so when we start to look at seasonal homes, then owner-occupied units, so you see the mirror image. So the average household size, your bigger sizes are in the middle. Your median housing values, again, predictably. Those seasonal homes are extraordinarily expensive coastal properties. In the middle, not so much. Median household income. So now we're looking at the median income. And you see where that denser areas, you've got more income. Labor force population, darker areas, more labor force. So you can see where that year-round labor force is. And then on top of that, we're going to look at unemployment. So you see the unemployment rates. So labor force, unemployment. And so then we look at residential, commercial, industrial parcels. And the potential developable open space, those red areas are those spaces that aren't developed now, that aren't protected in any way. That's where we go, we start to double the cost of wastewater cleanup, because if we allow that kind of development there. And then we're back here. But what emerges when you look at the GIS part of this is a tale of two different Cape Cods. There's the Cape Cod in the middle, and there's the Cape Cod north of the Kings Highway and south of Route 28 and on the Outer Cape. And so when you look at the ability to pay for wastewater solutions, which unlike transportation infrastructure comes almost exclusively from the local towns and from property tax owners. And you start to intersect some of that economic data that we looked at earlier, you have to ask the question. If you're going to put betterments that are $60,000 to $100,000 on that population density, that labor force, that year-round population in the middle there, what's going to be the result?
Foreclosure.
Foreclosures, for sales, and so what happens to the Cape economy when 25% of that housing stock goes on the market at the same time? In distressed sales. And the potential is an economic dislocation that could last for generations. So that's how important that economic data is, that's how important the GIS program is in approaching these big problems, which then again comes back to IBM and collecting information, synthesizing it, using it, analyzing it in a way to lower those costs, to make that affordable. So, you know, it's the intersection of all that we do. And I think over the last 3 years, it's breaking down the silos even in here internally so that information flows together and is useful to tell a comprehensive story about what the Cape is, what the real threats are, and how we're going to solve problems going forward.